Today's class we will be studying about dimensionless number, its importance, and with the help of dimensionless number how we are going to study about models and prototype. So, there you can see, coming to the dimensionless number. Once when we were studying about subcritical, supercritical and critical flow, Mach, sonic, supersonic, subsonic flow, there we have came across Reynolds number in the case of laminar, turbulent and transition flow, then Froude's number for critical flow, and then Mach number, that is nothing but ratio of velocity by velocity in C, V by C, ratio of V by C. So, there I have given a brief detail about dimensionless number. So, if you see, dimensionless number is nothing but it is the ratio of forces acting within a fluid flow. So, we have given certain names to certain ratios of flow forces acting on the fluid. So, obviously, they will, when same parameters are being compared or in a taken in a ratio, then they are dimensionless only. So, basically you can see dimensionless number as those numbers which obtain by dividing the inertia force by viscous force or gravity force or pressure force or surface tension force or elastic force. If you are dividing inertia by viscous, this one, inertia by gravity, Froude's, inertia by pressure you will be getting Euler's, and then inertia by surface tension you will be getting Weber's, and then if you see the Mach number, then it will be the inertia by elastic force acting on that body or acting in the fluid. You can also see that this is the ratio of, in this section, ratio of one force to the other force will be as dimensionless. Whenever we are comparing same parameters, it will be dimensionless only. So, we are terming the ratio of forces as dimensionless numbers. So, there are 5 dimensionless number: Reynolds, Froude's, Euler's, Weber's and Mach number. Dealing with the first one, Reynolds number. Reynolds number is defined as the ratio of inertia force of flowing fluid and the viscous force of the fluid, and there you can see that inertia force can be written as mass into acceleration. So, there you have written mass can be written as rho density into volume, and volume per unit time will be nothing but density into discharge, and discharge will be nothing but Q into A into V. And here you can see again you can see, let me take an eraser. This inertia force, which is nothing but m into A, mass into acceleration, is given to you as density, take the pen, density into discharge, and discharge is written as A into V, then velocity per unit time. So, this one we have done. Density into volume is mass, then acceleration is velocity by time. So, we are dividing this volume by this time, and this volume and time will be nothing but Q will be resulting to AV, and then again you are getting it as rho A V square. Coming to viscous force, similarly you can see it will be, viscosity will be in terms of shear force, then hence it is mu, change in velocity with respect to the length travel into the area you can see. So, if we are taking the ratio of inertia force by viscous force, what you are getting it as velocity into the diameter upon kinematic viscosity, that is ratio of dynamic viscosity to the density of the fluid. This is Reynolds number. Coming to Froude's number, Froude's number is defined as the square root of the ratio of inertia of the flowing fluid to the gravity. There you can see square root of inertia and gravity. Inertia we have previously calculated, and gravity you can see again mass into acceleration due to gravity. Mass you have written it as rho into A into L, and gravity is G, and there you can see this A into L will be nothing but volume. So, rho density into volume is mass, then this is acceleration due to gravity. And when we are calculating or simplifying it further, what you are getting it as, Froude number is at velocity by under root of G L, where L is the length and G is the acceleration due to gravity, having a streamline velocity as capital V. With the help of this Froude's number, you can calculate the critical flow and critical depth. While we are this time we are studying dimensionless numbers, so as to implement in the dimensional analysis maybe, or while studying about models and prototype. Euler's number you can see it is defined as the square root of the ratio of inertia force to the flowing pressure force. So, there you can see finally inertia by pressure, you are getting it as nothing but velocity upon under root of P divided by density. This is how you can calculate Euler's number. Weber's number is nothing but it is again the square root of the ratio of the inertia force to the flowing fluid of the surface tension force. So, after calculating inertia force under root with its surface tension force, you are getting a final expression or simplified expression as velocity by under root of surface tension into rho L. Coming to Mach number is defined as the square root of the ratio of the inertia force of the flowing fluid to its elastic force. So, inertia force you have already taken it as the same way, elastic force, under elastic force you have kept, or you can keep K into L square, and hence you can get a simplified form as V under root K P. So, these were the mathematical relationships which you have found out with the help of, as you can see, Newton's second law, or total force you can see is equivalent to force due to gravity, force due to pressure, and force due to viscosity, force due to compressibility, force due to turbulence, and force due to surface tension. This is the main equation. So, here what we have done, we have categorized certain ratios and named the constant terms like Mach number, Euler's number, Weber's number, Froude's number, and Reynolds number. This is how you got Mach number. Now, coming to the thing, what is the use, why we are calculating, why we are dealing with this term. Dimensionless number. What was the necessity of dimensionless number? Why we are using these dimensionless number in our study, and why we are calculating it? So, you can see that dimensional analysis can be assistance in various experimental investigation, and they reduces n number of variables. Like if you see, if you are calculating a certain phenomenon, let us suppose there is a phenomenon x and it is dependent on it is dependent on 5 other variables. So, with the help of these dimensionless groups, it helps in reducing the number of variables in this complex situation which you might be studying. This is the first point. Second point, from dimensional analysis they get how many number of terms are being used, like n m number dimensionless group, n is the total number of variables. You can see 1, 2, 3, 4, 5, like there were 5 variables, and m can be termed as the fundamental dimensions which we are having it as MLT. It also reduces the number of variables with the labor of experimental investigation. Then reduction in these variable is very important because it gives a clear study, it keeps the study intact, and you do not get mess up with n number of variables while studying the same thing. For example, Reynolds number is nothing but rho v d by mu. So, here you can see it can be changed by changing any one or more quantities. Here you can see you can change it by changing either one or two quantities, that is rho v d by mu, and hence Reynolds number can be changed. So, basic you can see, or you can summarize it as like it reduces n number of variable to certain less quality, that is n minus m terms. Coming to the similitude and types of similarities which we are having in models and prototype. So, the relation between the model and prototype is known as simulated or simulation, this you can see. Now, the variable results obtained at relatively small cost by performing a test on small scale of models and prototype. This similarity law help us, like how we are going to introduce this similarity law. So, this similarity law help us to understand the results of model analysis. When we are going to perform various n number of tests on certain of small scale of models of prototype. So, that prototype should have certain analysis, and that analysis is helping us to understand the future results which we are going to study, or which we are going to find out, or which we are going to face. So, these similarities can be of three types: geometric similarity, dynamic similarity and kinematic similarity. If you see the geometric similarity, then length, breadth, height can be seen. Kinematic with related to the velocity and acceleration, and in dynamics you can see that it can be related to the force, it can be related to the density of the fluid. So, we will be covering one by one. Coming to the geometric similarity, so you can see geometric similarity exists between models and prototype if both of them are identical in shape. Make sure they both are identical in shape, but only different in size. That is, let us suppose if you are taking, if your original length is 10 meters, then for that, for the smaller value you can take it as 1 mm, representing 10 meter as 1 mm, and on those scale you can work it out. So, the ratio of all these corresponding linear dimensions are equal, they will always be equal. That is, if you are talking about length, then length of the model by length of the prototype will always be equal to breadth of the model by breadth of the prototype, and hence height of the model to height of the prototype, or if there is any depth of the model to the depth of the prototype. This is the geometry which we have already told, I have given you the brief out. So, the ratio of dimension of models and corresponding prototype dimension is termed as scale ratio. If you are taking the ratio of the dimensions of model to its prototype, then that is termed as scale ratio. Scale ratio, if somewhere you are getting the scale ratio, means you are having this ratio. Coming to the kinematic similarity, kinematic similarity exists in models and prototype if they have been identical in, motion, that is motion in the sense of what? Velocity and acceleration only you can see. So, here you can see the corresponding velocity at corresponding points are equal, that is at point 1, let us suppose this is section point 1, this is point 2, this is point 3, this is point 4, point 1, point 2, point 3 and this is point 4. So, at point 1 you can see velocity of model by velocity of prototype will be equal. Coming to point 2, here you can see velocity of model to velocity of prototype will be equal, they are in the ratio, and here you can see at point 3 velocity of model will be equivalent to velocity of prototype. Hence, you can see there is at particular location with that scale ratio, you will be calculating either velocity or acceleration, and if their ratio are same, means you can see that, or you can say that, conclude that the model and prototype have or possess kinematic similarity. Coming to dynamic similarity, dynamic similarity is being seen if their forces are identical or you can see that the ratio of corresponding forces acting at corresponding point. The same example you can see, let us mark this is point 1, this is point 2, this is point 3. So, here at point 1 inertia will be same of what? Prototype and model, then viscosity will be same of prototype and model, force due to viscous, and it is not viscosity, force due to viscous, then force due to gravity and force due to pressure, force due to friction. Here you can see all the ratio of these forces will be equal at certain point in case of models and prototype, and hence we can conclude for the similarities there can be 3 types of similarity: kinematic, dynamic and geometric similarity. Geometric means simply geometry of the model is being taken, length, breadth, height, depth, and coming to kinematic, velocity and acceleration and motion will be same, you can see with respect to any point or location or any scale ratio, and then coming to dynamic similarity, forces can be seen at any particular instant. Coming to model testing, in model testing you can see like those who are engaged in creation of designs of hydraulic structures and machines, they always need to have model testing. They usually try to find out how the structure or how the machine would behave when it is actually constructed for this purpose. This is why we need to perform the experiments, and in fact the experiment cannot be carried out on the full size structure or machine, because once it is being erected or once it is in functioning section, and if it fails down, then it loses economically, it is not sound, wastage of time, wastage of money and wastage of concepts also. Then it becomes necessary to carry out these testings on a small scale. So, this necessity to construct a small scale replica of the structure and machine and tests are performed on it. This is how why we need testing of models or why we perform model testings. Coming to prototype and models. So, prototype is the actual structure of the machine or any structure, where you can see it has full size structures employed in particular actual engineering design, and it operate under the actual working conditions. Then like if you are supposed to construct a flyover within a span, you can see this is a circle and here you are supposed to draw a flyover. So, under this flyover you cannot simply directly construct the flyover for this particular span, because if it fails then it will hamper, it will destroy, it will harm many lives, it will affect environment, it will result in the wastage of money plus wastage of time. So, what we have done, the bridge will be having a model will be prepared to bear the forces, like the amount of force it was or the amount of load this particular bridge or flyover was feeling will be corresponding implied to that model, and this analysis or you can say this small scale analysis of the actual structure on the machine is known as model. These tests are performed on model to obtain the desired information, like we should be aware what all loads will be working in how many circumstances or how they will be changing their behavior according to the season, according to the loads, according to the various categories or various conditions provided in that actual conditions. It is not necessary that models should be smaller than the prototypes, they may be larger than the prototypes, you can see in the case of watches. Now, coming to the advantage of model testing. Basically, we have already covered the advantages of this model testing, but we can see that the model tests are convenient and economical, because when we are preparing a small scale, then it becomes convenient and it is also economical. Then all the defects of the models are eliminated. Once you are performing test on models, there you can see that you can eliminate all the drawbacks and you can increase the efficiency, you can obtain the desired result as per the demand over there. And then the final result obtained from the model test useful to modify the design of prototype. So, the final results which we are obtaining, those help you to modify or those help you to design a perfect prototype. Model testing can also be used to detect or rectify the defects of existing structures. Like if you are having some structure and it is not in a very good condition and you need to understand that rush is, like if you are taking an example of any lane, then in that lane you can see that day to day traffic load is being increasing and that structure is very old also, plus it was not designed for keeping in mind that number of load or that number of traffic. So, what you can do, you can take the dimensions and you can prepare a model of it and then you can substitute, put the corresponding subsequent loading on it, and hence you can rectify how that traffic can be reduced by it can be widened or not, or it can be taken into another lane, or it can be provided extra support from bottom, something you can detect or you can rectify. This is what they meant to see, that they can be detected or rectify the defects of the existing structures. Now, coming to the model laws. So, we have studied these dimensionless numbers, then help these dimensionless numbers, we have studied the simulation process or how the similarity law occurs. So, similarity law in models and prototype you have taken. Now, the next thing or last thing is that how we are going to construct or draw or these designing of these models. So, they follow certain law. So, law on which models are designed for dynamic similarities are termed as model laws. Once again I will repeat, the models that are designed for dynamic similarity are called model laws. And hence you can see that the ratio of corresponding force is acting on the corresponding point in the model as well as in the prototype, and they should be equal. So, for dynamic similarity there is a condition, that is it should follow model law. Now, what is the model law? There are 5 model laws. You have given 5 model laws in terms of dimensions, 5 dimensionless number. First one you can see Reynolds number, Froude's number, Euler's number, Weber's number and Mach number. Now, let us see what is Reynolds model law. So, Reynolds model law is the law in which models are based on Reynolds number, that is inertia by viscous force might be in dominating condition, and hence models based on Reynolds number includes what? Pipe flow. It can also include resistance experienced by submarines, airplanes, etc. Let us see Vm be the velocity of the fluid in model. This will be the density of the model, then length of the model, and this is the U, the viscosity of model. And there you can see, according to the law of Reynolds model law, there the value should be rho V L by mu, that is density, product of density of model, velocity of model, and hence length of model by the viscosity of model should be equivalent to the product or simplification of density of prototype to velocity of prototype to length of prototype by viscosity of prototype. If they are equal, means they are following Reynolds model law. Or you can see, if you have manufactured any model based on the Reynolds model law, then it is very clear that the Reynolds value for the model and Reynolds value for the prototype will be same. Coming to the Froude's model law. Froude's model law is the law in which the models are based on the Froude's number, which means dynamic similarity between the models and the prototype of Froude's number. For both of them should be equal. So, here we will be doing Froude's number for model and Froude's number for prototype. are equal. You can also see that Froude's number is also applied in following categories. You can see flow of jet from nozzle, here we apply Froude's model law, and again it can also be applied where the waves are likely to be formed on the surface. Wave formation on the surface can also be worked on or designed with the help of Froude's model law. Considering velocity, Vm is the velocity of model, length is the linear dimension, and g is the acceleration due to gravity m. All these m denotes model and all these p denotes prototype. If you are having Froude's model law or the models designed with the help of Froude's model law, they should be equal. Froude's value of model and hence Froude value of prototype are equal. Coming to the Euler's model law, again all these laws are nothing but that particular dimensionless number should be equal in case of models and in case of prototype. So, what we are doing, we have already studied what is Euler's law. Euler's number is nothing but it is the ratio of what you have got, velocity by pressure divided by density in square root. So, here it states that the dynamic similarity of model and prototype, both Euler's number in models and Euler's number in prototype will be same. With certain these assumptions, you can see we have calculated Euler's number of model and then Euler's number of prototype, and hence if it is based on Euler's model law, then they both will be equal. Coming to the Weber's model law, it is also nothing but Weber's number for or Weber's value for model should be equivalent to Weber's value of prototype. That is it. You can see this we have derived in our previous, let me show you once. See, these were numbers we have derived, so we need not study again and again like I was covering. This you have Froude's number, then Euler's number, this we have studied, then Weber's number we have already got V by under root of surface tension into rho L, then Mach number, and these for these number, if these numbers are equal for models and for prototype, that becomes their law. So, we have covered, you can see Euler's, Weber's is the same with Weber's. Weber's value is being calculated for model and for calculated for prototype. If they both are equal, then it follows a Weber's model law. Coming to Mach model law, again the Mach value or Mach value's dimensionless number will be equivalent to the model value and the prototype value, and it will be following this model laws. Coming to the types of model can be of two types, distorted and undistorted. Distorted means geometrical similarity is same, and undistorted means undistorted is geometrical similarity is not same, and distorted is geometrical similarity is different. Coming to the advantages and limitations, you can see vertical dimensions as it is a limitation, then cost of model is the limitation. Here you can see prediction of model is possible for us, results we can mend, we have already discussed, perfect geometry can be found out. Distorted model, you can see the model is not geometrical and similar, means geometry is distorted. So, it is distorted model. Advantage of distorted model, you can see accurate and precise measurements are made possible, and if you are coming to disadvantage, then depth and height distorted is changed because it is distorted model. That is all about the types of model, model laws and dimensionless number. Thank you.